question that almost all of us wonder about is whether matter in the universe came from nothing or existed from the very beginning. Currently, there is still no perfect explanation for this issue in the world of science. Only some fragmented theories, such as the uncertainty principle of quantum mechanics, vacuum zero-point energy, and other theories. According to these theories, the origin of matter in the universe can be said to come from nothing. To explain these theories, we still cannot separate from Mr. Stang's beautiful equation, the equation E equals mc squared. Although this equation is simple, it can explain the profound mystery of the universe, which is the equivalence of mass and energy, and they can be interchangeable. Matter in the universe is converted from energy, and in extreme cases, it will be converted into energy and disappear. This is the law of birth and death of the universe. The Big Bang model has become the standard model of modern cosmology, meaning this theory has become the dominant understanding of astronomers and cosmologists worldwide, the expansion forming today's universe. The singularity began from the Big Bang 13.8 billion years ago, going through an inflationary period and rapid expansion. Currently, it is still expanding at a speed several times faster than the speed of light, and becoming an observable universe with a diameter of about 93 billion light years. However, this does not mean that all locations are expanding faster than the speed of light, but refers to the expansion of the entire universe overlapping each other, at the edge of the observable universe, 46.5 billion light years away from us. The speed of galaxies receding from us exceeds the speed of light, and the speed of galaxies receding from us exceeds the speed of light. It can be said that the boundary between existence and non-existence is the singularity. In scientific terms, a singularity is represented by infinitesimal volume, infinite density, infinite curvature, and infinite temperature, where space-time ends. So the question arises, what is this singularity? How did it happen? Something from nothing, suddenly appearing from nothing? General relativity predicts that such singularities must occur, a phenomenon in which matter in an extreme gravitational field, influenced by quantum processes, and collides into a set of different space-time fields, such as the black hole singularity. On the other hand, the Big Bang is the result of recovery from another time and space. In this sense, the singularity is something beyond space-time, and it is no longer a space-time issue of the universe. The singularity is an extension from another time and space to our time and space. So it can be said that the universe was indeed created from nothing. There are two theories of modern quantum mechanics that explain this, which are the Heisenberg uncertainty principle and the vacuum zero-point energy theory. Heisenberg's uncertainty principle states that in the world, we cannot know the exact position and momentum of a particle simultaneously. From this, it can be inferred that even when the temperature drops to absolute zero, particles still vibrate. Otherwise, the uncertainty principle would certainly be. To explain simply, even if the universe perishes, with no space-time and only absolute vacuum, there would still be particle motion, and if there is particle motion, there is energy, and this is the origin of vacuum zero-point energy. In the space of absolute vacuum, these energies exist in the form of quantum foam, meaning they appear randomly as virtual particles. These virtual particles exist in positive and negative pairs, meaning they appear randomly as matter. When negative and positive matter meet, they annihilate each other and disappear after releasing energy. Therefore, these virtual particle pairs in the vacuum appear randomly and are immediately annihilated randomly. If the world were perfectly symmetric and balanced like this, our world would never exist. But physicists have discovered that the world is not perfect. The most prominent representatives are Zhang Zhenning, Li Zhengzhou, and Hu Shenzong with the law of parity non-conservation, which they explored and experimentally verified, winning the Nobel Prize in Physics in 1957. These theories suggest that our universe is not perfect, but occasionally there are violations of parity asymmetry, creating continuous changes in the world. Because of this, the scientific community has had a breakthrough explanation for the Big Bang, that these virtual particle pairs appear randomly in quantum fields, not 100% annihilated, but are destroyed to become a cosmic singularity. Our universe exploded from such a singularity, and there may be many other universes also exploding from this singularity. The singular energy is broken but not annihilated, so it cannot return to nothing, but can only expand, which is the Big Bang of the universe. The Big Bang was extremely hot and dense, initially only energy and nothing else. Within 1 second after the Big Bang, the universe rapidly gravity, gluons, quarks, bosons, leptons, protons, neutrons, and their antiparticles appeared successively, followed by the separation of electromagnetic force and strong and weak. After 384,000 years of expansion and cooling, the universe became large enough for hydrogen atoms to appear, finally emerging from the dark ages as the first light shone from the dense universe. At this point, common matter including atoms had formed. The earliest elements were the simplest ones, such as hydrogen, helium, and a very small amount of lithium. These light elements gradually gathered into nebulae due to gravity in the universe, then contracted and collapsed. And that was also the time when stars and galaxies in the universe were born. The initial stars were relatively large, so their lifespans were very short. In stellar nuclear fusion and successive supernova explosions, heavier elements were successively created, and the 118 known elements gradually appeared. It is precisely these elements that constitute all kinds of matter in the universe and living organisms on our planet. In this sense, the matter of the universe had existed earlier. Before the universe was born, energy was stored in a vacuum, and it was this enormous vacuum energy that transformed into various forms of matter. This aligns with the mass-energy conversion law, described by Einstein's equation. This is the process by which the known elements create matter in the universe and life on our planet. To my understanding, the matter of the universe was stored in the vacuum, and it was this energy that transformed into various forms of matter. This is the process by which the known elements create matter in the universe and life on our planet. This is the process by which the known elements create matter in the universe and life on our planet.